Hi, so my project name is Pyro, your Python assistant. And so welcome to the Pyro project presentation. Pyro is an advanced chatbot designed to assist developers to solve questions related to Python 3.1 documentation. So many times what happens is that you ask ChatGPT some question and it hallucinates, it makes stuff up because it doesn't have the context limitation only limited to the Python documentation. So I just want to ask some questions that's just related to Python 3.12, not related to any particular library. I want it to be natively Python. So this is is a smart search engine of a documentation. It's not limited to Python 3.12 because right now the training data set and the RAG vector data documents are limited to Python 3.12 documentation, but you can extend it into any documentation that you want, and we'll see further. So if we go further, introduction to Pyro-bot. So it's AI powered. It utilizes GPT-4 under the hood, and it's comprehensive. Like the entire Python 3.12 documentation was vectorized and passed through a RAG pipeline. It's efficient. It's fast because it uses the deployment on Azure OpenAI that's dedicated to us, and it's not subject to outside traffic. It's user friendly. It's built on the user friendliness and the UI UX patterns in mind. Some chatbot capability, it can highlight the syntax, it can help you with debugging, it has the entire library information of all the documents, and it gives the best practices because the examples come from the documentation itself. Architecture, so the UI is built using Streamlit, and the GPT-4 engine is using Azure OpenAI. We use VV8 for the vector database, and the RAG pipeline uses the transformer models internally for vectorizing those documents. So this is the architecture. First, you have the Streamlit that queries the database, queries the fast API backend. If you upload the file, the PDF is converted into text token using unstructured, and those text tokens are passed to a text to vector transformer model, where the vectors are stored in the VBIT database and the documents are stored in the vectors. And if you query, the query is also converted to vectors and text tokens, and those VV8 vector database search references are passed to the Azure OpenAI GPT-4 model, and those context is given as the input, and the response is then passed to the Streamlit frontend. So it's quite simple. If we move further, the data collection, so the document scraping is done through a script. We extracted the PDF documents from the Python 3.12 documentation sources. It was cleaned, removed irrelevant information, and tokenized into clean text and vectorized. So the RAG pipeline is simple. We use query processing. Each input is queried into a token, and then we wait cosine vector similarity function is run. Relevant information is retrieved, and the responses are generated using a GPT-4o model. So the performance evaluation, initially the accuracy is 94.5%. Even after fine tuning, it's 94%, and the response time is under 2 seconds. The relevance is 90%. Basically, its relevance is the pertinence of the query of the response. So improving metrics, we can fine tune the GPT-4 model, we can expand the knowledge base, we can give it more latest Python documentation, we can construct the feedback based on what queries it's failing, and we can fine tune it further, and we can optimize the RAG pipeline to use more efficient text-to-vector transformer models such as local llama, etc. So the deployment scenario, the deployment processes like the Streamlit deployment processes is done with automated scripts. We have the make file, we have the PyProject or TOML file. The cloud platform is the Azure OpenAI, but it can be deployed on any cloud using the native OpenAI API, and the user feedback loop is implemented consistently. Some future works, we can extend the knowledge base to other documentation. We can document other popular languages like Java, JavaScript, other frameworks like React, etc. We can also have a voice model interaction, like we can integrate the OpenAI's Whisper model to do a text-to-speech and speech-to-text output, and we can integrate into IDEs like JetBrains, PyCharm, VS Code, etc. So some demo time, we will see the demo of the project, we'll see how it works, and we'll get back here after that. Okay, so let's start chatting with this data. Let's ask How do I create a list? You get the answer. What is a dictionary? You get an answer. How to use a for loop? You get the answer with the syntax highlighting and comments. It all comes from the VV vector database. How can I read a file? You get the answer. Based on the provided context, you can use a file to read. So this is all done using vectorizing the query, context finding in the bigger database, and giving all to GPT-4. How do I create a list? It gives you answer instantly. The speed is amazing here because everything is happening locally and on GPT-4 custom deployment. What is the best way to merge? Let's ask more examples. Show me how to use a for loop. But this time we'll twist the question. So to it, we will ask, how can I read a file line by line and skip the lines? So we'll ask some questions that are not directly available in the documentation, but it will all take the context from the documentation and answer those questions. I need a list comprehension to filter out even numbers. You got the answer. Show me how to handle key conflicts with merging. So this is not available directly in the documentation. You get the answer. How can I read a large file efficiently in Python? Avoid loading the entire file into memory. So you got the answer. Now, asking some out of context question, this helps to filter out the bad requests. So, like, how does Python compare to JavaScript in terms of web development? I can't answer this question. How can Python be integrated into machine learning frameworks? I can't answer the question. Because this is not natively available in the Python documentation, we want to filter out this request. What's the difference between interface and abstract? I can't answer this question. If this were available directly to ChatGPT, it would try to answer those questions, but we want to only answer questions related to uh, Python documentation. We want to have those semantic search on the Python documentation. Now asking really random questions. How do you bake a chocolate cake? What are the benefits of regular exercise? These are not some questions that you want to answer. So now that we have seen the demo, let's see the conclusion. So Pyro has proven the valuable Python documentation assistant. Hope you like it. Hope it provided the accurate and timely information. Some key takeaways we can include is that the importance of continuous implementation. We can have seamless deployment strategy. We can look further on load testing, scalability, etc. Moving forward, Pyro aims to enhance the user experience like multi-language support. We can include other languages, localizations, etc. We can have code generation. We can have virtual reality integration. The sky is the limit here. So as Pyro continues to evolve, it will remain continued to its mission. Will I always keep the project open source and the documentations accessible and user friendly. Hope you like my presentation, and thank you so much. Any questions and audience feedback is appreciated, and we can get those comments in this video. Thank you so much.